3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Thank you all for coming for another Pass the Torch series today. We're so excited to have these during our celebration of the 50th anniversary of Apollo. And so we want to welcome you here to the Rocket Center. Many of you have been coming for a while. We have an encore performance today, and I hear from our presenter that it's been updated even since the last time that she presented here. So there's a lot happening out at Marshall and at NASA with space exploration, so we're very interested in hearing our speaker again today. Many of y'all know the Pass the Torch series brings research folks, practitioners, technologists, scientists, engineers, all of those involved in the current or past or future space exploration activities. So we're glad to be featuring those today. And today we're going to feature SLS, the Space Launch System. That system in its entirety, what it looks like from beginning to end, and where we are in that process. And that's what Marcia Lindstrom, our speaker, will speak about today. Let me just say, many of these panels are archived. They're oral histories for us. They mean a lot for us. We want to capture the presentations and the spoken word of our presenters for much significance. And so we're grateful to them. Intuitive Research Technology is our Apollo 50th Golden Anniversary sponsor. We thank them for being so actively involved here at the Rocket Center, particularly during 2019 and the 50th anniversary. We have a Pass the Torch sponsor also, Logicor. They are an analytical advisory and operational support services, and we thank them for supporting us as well. And we'd like to also note and recognize Glen Raven Corporation and Glen Raven for providing our digital archives support for these Pass the Torch series. Of course, we can't do this without all of our volunteers, and particularly on the 50th Anniversary Planning Committee, the chairmen of the respective committees, Heidi Collier, Benny Jacks, and Jack Stokes, and all the many, many volunteers underneath the many umbrellas that we have at the Rocket Center for giving us your time. We want to thank WHNT-TV and Rocket City Digital Media for doing our digital recordings of our oral histories. We thank them very, very much. So on with the show. The next giant leap of SLS, a very brief look at this particular vehicle, the brief look of how we got here through our heritage of expertise, and of course the status on the vehicle as well. And our presenter today is Marcia Lindstrom from NASA Marshall. Marcia leads the Strategic Communications Team for NASA's Space Launch System. Her time at NASA has included serving as External Relations Manager for Marshall Space Flight Center and the Headquarters Communications Strategist leading agency-wide exhibits. She's an Air Force veteran and came to NASA after more than a decade right here at the Space and Rocket Center. So she is family and will always be family, as many of us are. Please help me welcome Marcia Lindstrom for today's speaker.
All righty, so I normally don't stand up at a podium, and I may not stay here today, but things are happening very swiftly at NASA and at Marshall Space Flight Center and with the Space Launch System. How many were here the last time I was here and we had the tornado warning and rain? I can barely see you. Well, good. So this won't be, even if you were here, I've got a lot of updated information, because if you're paying attention at all to what's going on at NASA with regard to human exploration and the lunar exploration campaign, it is changing fast, and it is extremely exciting. And 50 years ago, and this is the nod I'm going to give, we never forget that we're standing on the shoulders of giants, and I know I say that every time I'm with you, and if you've heard me speak, and you know, if you've been around here since I've been around here, you know I love that Saturn V rocket, and you know I understand that when I say 50 years ago we pioneered a path to the moon, I mean you. and we thank you for that. We cut through the fictions of science, and we showed folks what could be done and what was possible. And today, we're called to explore with an even greater call to go farther than we've gone. We must be able to sustain missions of greater distance and greater duration. Once again, right now, we are pushing the bounds of humanity, and we are going to the moon by 2024 to stay, and this is how we're going to do it. I'm going to give you a little bit of I'm going to come down because I need to see that too. So let me grab this, see if I can do all of this. So back in February of this year, the President signed into law the Space Policy Directive 1. And it was very clear that we were going to return to the moon and that we were going to go to stay. Now, Space Policy Directive 1 did not say we were going to go in 2024. In fact, we had a plan. We knew it was coming. We were going in 2028 as far as landing on the moon. But that's not what the administration had in mind. That's not quite fast enough. But we will go to the moon in 2024, and we will do that by all means necessary. So I think I skipped a slide. This is where I want to go. So, Space Policy Directive 1, this is what it includes, and it's very clear on what's different. So the President says we're going to go back to the moon. We like to say, and the administrator in particular, Jim Bridenstine, likes to say we're going forward to the moon. And why is that different? Well, because we're going like we've never gone before. And you'll see what's different embedded in Space Policy Directive 1 in the words highlighted here. So you see that we are going sustainably. What does that mean? It means that we are going there, we're going to stay there, we're going to have a human presence, and that is part of the mission, not just in getting there. We're going there to stay. We're going there with our commercial partners, so this kind of an endeavor takes all of us. We're going to need commercial partners not just for other launch vehicles, but for scientific payloads, for possibly small rovers on the moon, lunar landers on the moon, all of that. So we need our commercial partners. We also need our international partners. So for Moon 2024, which is the new directive, and I'm kind of getting ahead of myself, but Canada has already signed up. We're in talks with every one of our partners that are on the International Space Station, but Canada is signed up, and they didn't just sign up to go for the first little while. They're signed up to go with us for the next 24 years. So it's not just us. This is a commitment by our international partners, and we're going to need that. The other thing that makes it different is that the United States is going to lead a return to the moon. That's the first part of it. We're building a coalition of nations that will return to the moon for long-term exploration and utilization. So that's the other word that's really different, utilization. When we went to the moon the first time, it was about getting there, right? And all of the exploration we did was around the equator. So what we knew of the moon was what was happening equatorially. That's where we were exploring. So what we knew was there. Well, that's like saying, like going to a diner in New York City and saying you've seen America. I mean, it's limited what you can know and what we did know with that exploration. So that's what Space Policy Directive said. We knew it was coming. We were ready, as I said, by 2028. Well, who was here? I think some of you guys were here when the Vice President stood right here and said, it is the stated policy of this administration and of the United States of America to return astronauts to the moon by 2024 and follow that with a sustained presence in 2028. That's real different. Now, I'll tell y'all how the difference between people who are communicators, that'd be me. I want to manage y'all's expectations. I am not a rocket scientist, nor am I an engineer. I'm a communicator. So when you tell me we're going to go do something like return to the moon in 2024, I am ecstatic. I am jumping up and down in my seat. If you're an engineer who's been planning to go back to the moon by 2028, you might be looking at your shoes right now, because that is a very different mission. But I can tell you that it was a charge issued and it was a charge accepted. And one of the things I want to show you today is some of the architecture with Artemis. Have you heard of Artemis? That is the new name of the NASA's Lunar Exploration Program, and it covers a whole swath of things, and we'll get a little bit more to that. So why are we going to the moon? Why bother? We've been there, we've done that, right? Well, I mentioned a little bit of it. We go for these reasons here: to establish leadership and a strategic presence, to prove technologies and capabilities. How far away is the moon? Right about that. Exactly. Well, so let's start. I'm going to go backwards. If you were here last time, you've seen this. How far is the International Space Station from the Earth? So the moon is about 1,000 times farther, right? So Mars is about 1,000,000 times farther than the moon. And I'm thinking, if we're going to continue and learn how to live and work on a different world, perhaps we start somewhere closer than 390 million miles away on a trip that takes no less than 9 months. And to get there, everything has to line up. Do you know how often Mars and the Earth line up so that you could do a mission to Mars? 26 months. Okay, hush. You hush, you hush. It's only every 26 months. So if you're going to go, you're going to have to go prepared to stay. And so that's one reason to go back to the moon. It's a proving ground. We've been saying that for years, haven't we? We've been saying proving ground for as long as I've been attached to aerospace, and that's about 17 years. That is the truth. We need to prove our technologies and our capabilities, buy down risk, figure out how to utilize the resources on the moon, and we'll talk more about the resources on the moon, and understand how to do that before we venture on to Mars. That's one of the reasons to go back to the moon. The other reason is that it does allow for full participation by commercial and international partners, and you'll see that as we talk about what this architecture is. So it allows all of this, and in the meantime, it broadens industry and international partnerships in deep space, and that's extremely important. One of the things, when we get in a little tussle down here or a disagreement with Russia on our earthly geopolitical stage, we don't have that problem in space, do we? We're still living and working together in space, and we have been off and on for about 25 years. Since 1975. If you go back to the programs, that's important, y'all. That absolutely matters, and that's one of the things that going with the coalition leads to. So, was born just a few weeks ago, Artemis. Now, Artemis is the twin sister of Apollo in Greek mythology. And I know there are several stories, about the different stories in Greek mythology about Artemis, but she was the twin sister of Apollo, and she's the goddess of the moon, the goddess of the hunt. And considering now that we have more diversity in our astronaut corps than we may have ever had, the idea to have Artemis as the name of the lunar exploration missions makes perfect sense. So Artemis, the twin sister, when they land, Artemis astronauts will step onto the lunar surface at the South Pole, and with the horizon goal of sending humans to Mars. This is just the beginning of that exploration. So let's talk about, and this is the one where I want to make sure I'm getting everything right, because this is the important slide. This is the how of how we're going. So take a look. You can see on one side of the swoosh is 2019. And I believe that's right. Yes, 2019, and then on the far side is 2024. And that gives you the span for Artemis 1, because we're going in phases, right? The first phase is about speed, get there, and get there fast. And the second phase is about sustainability, get there and stay. So let me ask you all, and I'm going to take a little liberty here. Why do we have to go fast? Why does it matter? We haven't been in 50 years. What's the point? Why is it? Enthusiasm. Anybody else hazard a guess? Trump? Anything else? It could, you know what, I'll take you up on that, but it could be Trump, it could be Obama, it could be anybody. It could be Bush, it could be anybody. The point is, part of the need for speed is that we need to buy down political risks. If you've been associated with aerospace any time, you know nothing kills a program quicker than time. Because administrations change, priorities change, everything changes. And the need to get there and establish that presence then is very important. The other thing is, the time is now. We're ready. We have international partners that are ready. And there's no problem with a forcing function to actually get there and have this coalition of partners. And actually, it's very nonpartisan, as a matter of fact, the way they're going about it. And this architecture ought to explain some of that. So let's look, 2019. Artemis 1, we're at 2019 right now. Artemis 1 will launch in 2020. That will be the first human spacecraft to the moon in the 21st century. That is an uncrewed mission, SLS and Orion, to the vicinity of the moon. And we'll talk a little bit more in depth about that when we get to towards the end of the presentation. But that's the first step. We're going to do that in 2020. It is uncrewed in the vicinity of the moon. It'll test out all the systems and make sure SLS and Orion work together. The second stage, or the second step, is Artemis 2, which is the first time humans will return to the area of the moon in the 21st century. Now, we're going to test out on that flight the life support systems and all of the human systems necessary to keep astronauts alive, but we're going to do that in Earth orbit. We're not going to do that at the moon. We're going to test those out in Earth orbit. Then we're going to go to orbit the moon, but a free trajectory to return. So we're not trying to get down to the surface of the moon. We're coming back. So that's Artemis 2. That's about 2022, I believe. I want to make sure I'm telling you right. That's, yes, about 2022, testing out the metabolic and life support systems. So 2022 and 2023, we need to start building up the gateway, right? Have you heard of the gateway? And it was, in the beginning, it has morphed several times. In the beginning, it looked like a very large station, similar to the International Space Station in orbit around the moon. That never was the intended purpose, and it's certainly not what we're going to start building up in 2023. We're going to need the minimum, the things necessary for a 2024 landing. So we're going to have a power and propulsion element. We're going to have a utilization module. They don't even want to call it a habitat because it's very small, and its intent is to allow a place for the astronauts to get there. It's just a utilization model. They call it the Astro Den in less formal settings. But that is, we're procuring the power and propulsion element, and I think we announced last week, Mark, didn't we announce last week that Maxar, I believe, is building that power and propulsion element. So we just announced that, which is a very different way of procuring things. We'll also have that utilization module, and that's to get humans into a lander and down to the surface of the moon. And then finally, we'll need that lander. And we have an RFP out there that's asking people, we're saying, here's what we need to do. We need to get to the surface of the moon. Tell us how you're going to do it. And we're going to buy that service. If you've been around NASA for any length of time, that's really different. That's doing it very differently. The power and propulsion element, for instance, we will test that out, and we will have the opportunity to take possession of it on orbit. So that is very, very different. Many of these systems that we're talking about, we will not own, we will not operate, we will not maintain. We will buy a service. So in 2024, we will have the elements of the gateway built up, and we're going to need that. I think I can point. This is where I am right here. We're going to need that because we're going to launch humans to the south pole of the moon on Artemis 3. That takes astronauts to the gateway, and that gets them into the lander, down to the surface, and on to the South Pole. That's in 2024. And in the meantime, so all this stuff you see here down on the bottom, in the meantime, we need our commercial partners to help us do lunar surface activities. And some of those include, one of the things you may have you heard of the CLIPS program? Commercial Lunar Payload Services. That's small scientific payloads, so about 15-pound scientific payloads on the surface of the moon. I think there are 9 companies who are saying right now they can do these surface activities, and this is to pave the way for humans to go on the moon. So some of it will be small rovers, some of it will be small landers, not human landers, and then ultimately the landers. So that is the big, broad plan from now until 2024. So I've mentioned all this, so now how do you do that? I mentioned one of the reasons it's not quite as partisan as it could be, is because we need everybody to achieve a launch in 2024. So on the top, they're trying to show this as a parallel path. We have to have that in order to get to the moon in 2024. The top you see are the NASA missions with SLS and Orion, and let me just say this right at this point. We have looked at everything to decide if there is any other system besides SLS and Orion that can get us to the moon by 2024. And the answer is no. This is the system. And we have waited for that to be said. We've known it. We've been waiting for that to be said with authority. The administrator was down at the Florida Institute of Technology to announce the award of the Maxar for the power and propulsion element. And he said, let me be clear, which is one of his favorite things to say. We've looked at everything, and this is the system. So Artemis 1, 2, and 3 to get humans to the moon will be NASA and will be SLS and Orion. You can see there the missions I've already outlined. And then at the same time, we're going to be using our commercial partners and industry partners to deliver the landing systems necessary to return to the moon and to do that sustainably through the Gateway. We're going to talk more about all that. I just wanted you to see the big picture. So while we're doing this, between now and 2024, they're doing this. And so, for instance, we said in the beginning, we put out an RFP, we want this kind of lander. And, you know, we want an ascent, we want a descent module, and then we'll go from there. We're telling them now, you tell us how you think you can do it. And we'll prove that out. We'll prove that out, and that's the service we'll purchase. So all of that, I'm saying that to tell you it's not just direction that's changing. It's how we procure and how we get the systems necessary to get to make these exploration missions complete. So that is the architecture.
Are they getting federal funding while they're trying to create these prototypes, or like you said, you're not going to purchase them unless you know that they're working?
Right. The CLIPS program, they do get some funding. They, to put forward an idea, but these others have said we'll do this, and we're saying do it, and then we'll buy it. So it's venture capital. It's venture capital. It's very inexpensive to us. It's very, very risky, and the rewards are fantastic. So one of our former center directors, I said one time, this is like the golden age of space exploration again. Right now it's happening. Von Braun would be thrilled if he knew we had a fleet of rockets to choose from. He probably wouldn't be surprised because he had that much vision. But the fact that we can go to commercial and international partners, and it's not just us. And that center director said, I would tell you it's a gold rush. And many will try, and few will make it. But those that make it, boy howdy. I mean, it is like venture capital for those missions. Yes, sir.
One of the statements you made was that going with SLS because that's what looks like the certain thing. So you're discounting any of the commercial things, space.
Falcon Heavy or Delta IV. Yes, those studies were done. I don't know back. It was a terribly traumatic time for me working for SLS, but there were several studies done just a few months ago. I mean, all of this has really kind of gotten to where it is since March the 26th. We were doing some studies before that, but we looked at, can you do it with a Delta IV Heavy and a Falcon Heavy? Can you do it with one Falcon Heavy? Can you do it with this? Can you strip down Orion enough to get this? And the answer was no. Just not capable of, and part of that is what Orion is as a human, as a human spacecraft, has some requirements. So let's talk just a little bit about Gateway. This is, you can see the solar panels that are here, and you can kind of get the relative size. This is the lunar landing system that we expect to have there at 2024. This is Orion on approach to bring the astronauts. And this is Gateway Phase 1, which is that power and propulsion element, and the Astro Den. They'll probably kill me we're recording this. Okay, so it's a utilization module. But what it does, this initial form of the Gateway focuses on only those things mandatory to get astronauts to the surface of the moon in 2024. But it also provides a foundation for the eventual build out that we'll need to have a sustainable presence at the moon. Gateway is absolutely key to sustainability at the moon. You can consider it a permanent command service module in the orbit of the moon. This first phase 1 Gateway, the smaller one that I'm telling you about, they expect it to be in orbit around the moon for 15 years. It will be in a near rectilinear halo orbit. So for those of us like me, what does that mean and why do we care? I mentioned earlier that the Apollo missions to the moon went like this, around the center of the moon. What Gateway allows us in that near rectilinear halo orbit that allows us to be balanced between the Earth's gravity and the moon's gravity is we're orbiting like this. So we have near constant communications with Earth. We have sunlight for power because this will be powered by solar electric propulsion. So that allows us this small, tiny little thrust that allows us to maneuver in our orbit around the moon. And what it really does is provide us access to any area on the moon anytime we want it for any reason. This is what really gives you that sustainable presence, because there will be interoperability standards that allow other people to dock. If you're a commercial company and you want to dock at the Gateway, great, go ahead. If you're an international company, international country, you can do that as well. But that stays there, and that is what allows us to do lunar surface missions, robotic and human. So does that give you a good idea about what Gateway is? And it really is the reusable and sustainable part of this first Moon 2024 that we're talking about. And it will be the building blocks for the future, more built out version of the Gateway. So I'm not even going to go over this. I want you to kind of just take this in a little bit. But this is the science. So we mentioned earlier, why are we going back to the moon? A lot of it is science. It is a scientific treasure trove. We've had, so this is, I think, a decent example. Precious metals on Earth are not derived here at Earth, right? They hit us from meteorites or other bodies hitting the Earth. And then once they hit Earth, because we have a very active hydrosphere, atmosphere, they don't stay where they were. You know, they're hard to find, and you only find them in trace elements. Well, on the moon, once it hits the moon, wherever it hit the moon, it's there, like it was when it hit the moon, because it does not have an active hydrosphere or atmosphere. So that allows us all kinds of science on the surface of the moon. And these early scientific missions, and I mentioned the rovers and the small scientific payloads, that's paving the way for humans. That's telling us where are the best places to land, where all of that stuff is going on between now and 2024. One of the unique things about SLS, and we'll talk about it just a little bit when we get to the rocket, is the 13 CubeSats that will ride along on Artemis 1. There are 13 scientific payloads, boot box size, 6U CubeSats, with world-class science for pennies on the dime. And there is an image right now. We had one of the payload groups that's from Moorhead University in Kentucky. They were just here past their third phase safety mission, and they had a picture of them in front of the LH2 tank in the test stand. And it's these kids who are going to be looking for water in all of its forms on the moon with Lunar Ice Cube, which will be one of those 13 payloads. And NASA will also, and Marshall will also have one, JPL, international companies, but that kind of science is going on right off the bat with Artemis 1 aboard SLS. So, if I said to you, what's the most precious resource, what do you think, well, let me take that back. What do you think we're going to be looking for first at the moon? I've already kind of given it away. You'd think water, right? Air to breathe, water to drink, rocket fuel. But actually, they're going to be looking for light. They're looking for places that have, they call it permanent, peaks of permanent light and darkness, because what that allows you, and somebody asked me if we were doing science in Shackleton Crater the last time I was here, and I could not answer that question. But these are the missions that are ahead. They're showing you the illumination at the South Pole. That's Shackleton Crater, and you can see the lighter it goes down here is 100% illumination, so you can see there's very little of that, or 80 to 90%, and then it goes up from there. You can see that it is dark, and in fact, it's totally dark inside of Shackleton Crater, which allows us to look for water there. So this is an oblique image, an oblique view of Shackleton Crater. That little tiny rim of light gets about 80 to 90% illumination all the time. So that's a neat place to be. And then in here, there's no light ever. So we believe that that is where you could find, as the administrator says, hundreds of thousands of tons of water ice at the south pole of the moon. Now you think about what we always think we know. Anybody ever seen Men in Black? I'm sorry. So one of the quotes in that, and I'm not going to say it exactly, but they say, you know, in 1492 or whatever, we knew the earth was flat. And and he goes on through this list, and I'll say in 2007, we knew there was no water on the moon. And in 2008 and 2009, LCROSS showed us that, yeah, there is. So imagine what we'll know by 2024. Sorry, you'll have to forgive the quote. But that's the Shackleton Crater, and we do think there are tons and tons and tons of water ice in Shackleton Crater. So we're going to be looking at places like this that offer us the light we need, but also offer us the opportunity to look for those resources we're talking about.
Do you need light or solar power?
We will need light for solar power, but I don't know the wherewithal about solar power for landers. I don't know what all that looks like, but I'm guessing that's part of it, and especially if you're going to be there sustainably. So it does matter.
Could I
Yes.
ask you, if you're asking questions from the audience, let us get that question on the mic.
Oh, okay. Well, I'm not asking them. They're throwing them at me.
But I was asking.
But I'm happy to answer, and I don't mind you doing that. So please, if you want to hold up your hand, I'll come to you at the microphone. But yes, we are looking for water, and we are looking for light. And I can tell you, so all of this hinges on Artemis 1, right? Got to launch that first one. Got to do it. And it demands a heavy lift rocket able to carry astronauts aboard the Orion and the things that they need in one mission to get there. And guess what? We're building it. SLS and Orion. That's what's going to help us take that next giant leap. That's what's going to make us successful in the human landing on the moon. So this is it, the first version of Space Launch System in Block 1 configuration. So, and I'll show you just in a minute, but one of the beauties of SLS is that it is evolvable. But this is the one that'll carry us on the first missions, Artemis 1, 2, and 3. So what you're looking at is the expanded version. You've got 4 RS-25 engines. They are built by Aerojet Rocketdyne. You've got 2 5-segment solid rocket boosters built by Northrop Grumman. You have the core stage of the rocket, which includes the engine section, liquid hydrogen tank, inner tank, liquid oxygen tank, forward skirt. All of that is being built by Boeing down at Michoud Assembly Facility down in New Orleans, and that is the big new development. You know what comes with big new development? Challenges. And it has proven, you know, that that's part of it. Above that, you'll see the launch vehicle stage adapter, which was built right here at Marshall Space Flight Center with Teledyne Brown as a prime contractor on that piece. That is getting its frangible joint attached right now, and it looks like it's probably going to have to wait its turn, but it's going to be ready to go at the end of the month. But I think we're probably going to keep it here as other parts move all around until we're ready to use it. Interim cryogenic propulsion stage, Boeing and United Launch Alliance, that's a modified Delta IV upper stage with one RL-10 engine, also produced by Aerojet Rocketdyne. And then you can see above that, oops, I keep doing that, I apologize. The adapters, the ferret, the panels, and then the payload. Anybody here from Orion? Actually, that's the Orion spacecraft and the launch abort system. All remarkable, and the European Service Module. So European Service Module, and I've got some progress video or progress shots from Orion. European Service Module is already down at the Cape. The Orion crew capsule is at the Cape finishing up. The launch abort system, I think we delivered the engines for that. If not yesterday, then in the next couple of days. So all of this is what makes up the initial configuration of Block 1, but this is just the beginning of this rocket. The beauty of it, as I mentioned, is that it is evolvable. And you'll notice from here, well, about here down, the core stage is the same, right? So once we get that thing developed and built, we will use it over and over and over and over. Yes, sir.
Who's the integration contractor, or who's doing the integration for the entire program?
I think the integration contractor, I think it's Jacobs at the Cape. I'm not positive, but that's what I believe. So I will tell y'all, I do not profess to be an expert on the other programs because this is my baby, is the rocket. So, but I will try to answer, and Bob, I can get that to you at another point. But what you'll see here is the capabilities of the rocket. So the Block 1 and the Block 1, there's crew and cargo versions of each block configuration. And you can see the capabilities, 8.8 million pounds of thrust. You can see above what it's able to carry. I don't love this chart because it's still got payload to low Earth orbit on there. This is not a low Earth orbit rocket. We're not going there. It doesn't matter what it can carry to low Earth orbit because that's not the measure we're trying to get to. It's a deep space exploration rocket, and what it can carry to translunar injection to get to the orbit of the moon is what matters. So this first Block 1 version can get about 26, right at 26 metric tons, greater than 26 metric tons to TLI, which I believe is about 37,000 pounds, and if y'all can read that, you're doing better than I am. As we go up in the blocks, we will have advanced boosters and an exploration upper stage. So I mentioned to you that the in-space stage, when I showed you the expanded version, the interim cryogenic propulsion stage had one RL-10 engine, right? The exploration upper stage that's in the minds of the folks right now has 4 RL-10 engines attached. And it also gives you one of the things that exploration upper stage also gives you is if you're trying to carry a lander to the moon, and any of you guys that work lander can correct me, but I think diameter matters for stability, and that larger exploration upper stage gives you that as well. And you can see that the capability goes up 11.9 million pounds of thrust, and what it can carry eventually to TLI is greater than 45 metric tons or about 100,000 pounds. It is a beast. And I don't know how many studies have been done. Do we actually need a heavy lift rocket? And over and over and over again, we come back, yes, indeed we do need a heavy lift rocket. Fortunately for us right now, we have a fleet of rockets, but we still need the heavy. Yes, ma'am.
Are these engines being tested now and being tested here in Huntsville?
They are not being tested here in Huntsville. The RS-25 engines, the liquid engines, for the first 4 missions are already done. We had some left over from the Space Shuttle program that have been upgraded and modified to fit the flight profiles of the SLS. The first set is already, well, not yet, and I'm getting ahead of myself, but we've been testing those at Stennis Space Center since 2015, testing out all the new controllers and all of those things. So yes, we're testing those engines. The boosters have already gone through their qualification motor test at Promontory, Utah, at Northrop Grumman's facilities there. So yes, that testing has been going on. And right now, we've been in the largest structural test phase at Marshall Space Flight Center, probably since, for sure since shuttle, maybe even longer than that. So what's unique about, and I'm going to talk to you, I want you to think about this as the evolved version of SLS. So what it offers you, it's not just that it's a heavy lift vehicle, it's what it can carry in volume, what it can lift in mass, and the departure energy. So with volume, we're talking about double the volume of any existing rocket. And why do we care? Well, that makes mission design a whole lot simpler when you don't have to fold stuff up like origami, right? It makes missions less expensive, it makes them less complex, and higher chances of success. So this one, ours right now, gives you double the volume of any existing launch vehicle. Mass, 50% more mass than any contemporary launch when we get to Block 1B. And the Mars enabling capability of greater than 45 metric tons to translunar injection. So that's Block 1B, you're getting that kind of mass. And then probably as exciting to anybody who's interested in science of all of these is the departure energy. So it cuts in half the time to destinations than any other rocket. So if you were going to Jupiter's icy moon of Europa and doing the Europa Clipper mission, on any other rocket it could take you 6 to 7 years because you can't go VFR direct. You have to have assist, and off you go. With SLS, you could go direct, and that cuts the time in half. And why does that matter? Because if you're a scientist, you're a PI on a mission, on a science mission, you want that data, right? And it also cuts down time and space and also makes things less complex. That's what makes SLS kind of unique when you're looking at the family of rockets, the fleet of rockets that we have. So SLS, lest you think you are not involved in this already, I don't care where you're from, you are involved in this. More than 44 states involved in the building of just SLS. More than 1,100 contractors supply parts and pieces for the Space Launch System. It is absolutely America's rocket. And you can see there the economic impact. That's no small thing, and it doesn't just matter to legislators and elected officials. That's extremely important because what that means is that the economic base is being grown. And I'll give you a real quick example. We were just in Michigan at Futuramic. And Futuramic builds the tools that we've been using at Michoud to build the rocket, and they've also built new tools to help us accelerate that work. So we were doing vertical integration, now we're doing horizontal integration, and that's been made possible by Futuramic in Michigan. Great company. They were dying. All of their business was outsourced that they were doing for Ford was outsourced out of country, and they were dying. And they knew if they didn't make a shift, they would die. And it was an old company with a great heritage. They shifted to aerospace, and they are booming between the defense sector and straight up aerospace. And one of the things that was interesting is, and this is where you kind of get the real and story. We're sitting in the middle of a big NASA thing, and the main guy points to me and he said, "You see that tool right there, the holder or carrier or whatever, it's a piece of tooling." He said, "That's not yours." And it'd been in all my shots, and I'm a communicator, so you know I care that that's not my piece of equipment. And he said, "That's Blue Origin's." And I said, "Well, gee, John, thanks for that." You know, he said, I didn't say that. I said, "Oh," and he said, "The reason we have that business is because we have your business. And when people want to talk about expense, they can thank you for buying down expense for them, because it did not cost Blue Origin what it cost you because you made the model. You brought down that cost." So he has Blue Origin business because he has NASA business, and that matters in our economy and being a leading industrial nation. So, and if you're talking about, I said 44 states, if you talk about the exploration ground systems at Kennedy Space Center and the Orion spacecraft being managed out of Johnson, it's every state in the nation is involved. And 3,000 small company, or large and small companies, and 17 international countries involved. This is, I just said the international countries, but it is America's rocket. So let's talk about where we are. The solid rocket boosters, 177 feet tall. This is a 5-segment booster compared to the 4-segment booster for the space shuttle. It has new asbestos lining, new nozzle, asbestos-free, insulation, new nozzle. We've been testing those in Promontory. That's an image of the qualification motor test 2, and I'll let you look at some of the videos. Some of you guys have already seen this. But those boosters, let me see, I'm going to have to check because I got too many numbers in my head. I believe 3.2 million pounds of thrust each. They burn through 1,385,000 pounds of solid propellant in the 2 minutes that they burn. You know what that equals per second? 5.5 tons per second. And you can see here some of the testing going on at Promontory. They will give us, of course, the initial amount of boost that we need. You can see the testing there. So when you think about it, you know, I say 177 feet tall. That doesn't mean very much. That's a 17-story building. That's taller than the Statue of Liberty. It actually is something. And where we are right now, and let me tell you where we are with the boosters because I want you to know where the status of those is. And I do have to look at this because it changes daily. So qualification testing is complete. All 10 motor segments for Artemis 1 are ready and waiting shipment to the Cape in August of this year. And all 10 motor segments for Artemis 2, the second mission that will carry humans into the vicinity of the moon, they've been filled with propellant and they're also being processed. So let's talk liquid engines. So the liquid engines, as I said, we have 14 flown engines from the Space Shuttle program and 2 that were put together with parts of others that are left over or heritage hardware from Space Shuttle days. The only difference is they've been upgraded like crazy for the flight profiles of SLS. 512,000 pounds of thrust each. You'll see them here where they are on the vehicle. 512,000 pounds of thrust each, or 12 million horsepower. So that's like, I think, 13 Hoover dams. And if your car's engine was as efficient as the RS-25, it would fit in the palm of your hand. This is a test down at Stennis Space Center. All that testing's complete. The 4 engines from Artemis 1 will be delivered in the middle of this month. In the mid-June, they'll be delivered. And they're already boxed up, ready to go. That is, has anybody been to an RS-25 engine test? Pretty super cool. We'll also be doing some, we're looking at doing a green run test down at Stennis Space Center in next year, but it is not an engine test. It is a test of the core stage, which we're talking about here. And I don't know if I've got video on this first one or not. Yeah, I thought I might have a video on this is at Marshall Space Flight Center. We did this over furlough. So while we were all off work in January, some folks weren't, and delivered the liquid hydrogen tank, which is the largest piece of the core stage, to Marshall Space Flight Center. This test stand is on the foundation of one of the Saturn V test stands at Marshall. There's a cool shot, and if you'll follow me on Facebook, you'll see there's a cool shot from where you can get behind one of the F1 engine test stands, and you see in the background this test stand, and it is a super cool shot because it's not just past and future. That F1 engine test stand is where Blue Origin is going to be testing their BE-4 engine in the near future. So, and what you're seeing here on this side, that is the Forward join, we call it. So that is the forward skirt, the inner tank, the liquid oxygen tank, and all connected there together. And what's cool about it is that we have since even done more than that. So let's see if I'm missing anything on this. A little over 200 feet tall with a diameter of 27.6 feet, stores fuel for the RS-25 engines. It holds 537,000 gallons of supercooled fuel at minus 423 degrees. And you can see, I think it's important for you guys to see this hardware on the move. There we go, that's what I wanted y'all to see. 80% of the core stage is now together. 4 of the 5 main pieces have been assembled. 360 bolts torqued to put that liquid hydrogen tank to that upper stage, and you're seeing here some of those pieces. That's the liquid oxygen tank. That's it going into the forward join, which was the first of 3 major joins. That was completed earlier this year. All of that video you're seeing there. So that's the upper third of the rocket. And then that's the Pathfinder vehicle that helps us test out all of our moving equipment, how are we going to move it, how are we going to lift it, all of that stuff that was built right down the road in Coleman, Alabama by a company called G&C Steel with Dynetics and Radiance, I believe, involved in this. Now, the reason I'm showing you this we just finished last week. So that's a person right there. And this is that whole joining of the 4 of the 5 major pieces of this rocket. Now, there's still things going on to outfit, but structurally, these pieces are structurally complete. And now readying for rollout of this whole stage. The second part of that will be we still have to get the engine section and the boat tail. Engine section is one of the most complex engineering feats, they tell me, that we've ever accomplished. And it holds everything that those engines will be loaded into the boat tail or integrated and then integrated into the engine section. And all of the talking between all of this and that engine section and those engines comes through there. The inner tank, I don't know if I've got another. The inner tank, let me say one thing about that real quickly. That inner tank, and I don't have a model either, it's a rigid part. I can show you on a later image, but it takes all of the forces from those solid rocket boosters. So that thing is rigidly built. While the rest of the core stage was done with self-reacting friction stir welding, that inner tank between the LOX and the hydrogen tanks was hand bolted because it has to take the forces of those boosters and keep them there, you know, as the thing lifts off. So the in-space stage and the adapters, these are done. This is the interim cryogenic propulsion stage that I showed you earlier. It's in its can at Kennedy waiting. This is the Orion stage adapter that was built here, went from concept to done in 18 months, and it is what holds those 13 payload. I think I've got video on that, so I'll hold to show you that. That holds those 13 CubeSats are inside there. And then this is the frangible joint going on the launch vehicle stage adapter. This is the last piece of flight hardware that we're going to have at Marshall Space Flight Center. Once it's delivered, we're through with flight hardware. We will have some structural test articles still here, and some of that testing will continue. But so this is where it fits on the right. Okay, so this is the inner. I missed it. I thought I was going to be able to catch it. Launch vehicle stage adapter and all the pieces of the upper stage. This is it being completed at Marshall Space Flight Center. A lot of you guys already know this, but fun fact, you saw him applying the thermal protection system. The young person who was responsible for figuring out how we're going to hand apply this, because we had to figure out a new way to do it, because that's the largest piece we've ever done that with, and we had to hand apply it, is a Cabot, Arkansas 5th grader who came through space camp years ago, and she might be 26, Auburn grad, and she led that team that did that, and that's one of your space camp alumni. So it's no small thing what happens here, and she just came for 3 days, if I remember how Cabot, Arkansas rolls in the door, which I do. that is where you folks your space campers end up. So that is the rocket and where we are in completion. And you can tell there's a lot of, Bob Springer asked me earlier, what's still ahead? If all these pieces are structurally done, we're getting over the challenges of the build of the core stage. Integration. I don't know how many of you have a little shiver when I say that. There's a lot that goes on with integration, and we still have all of that to do. But we plan to roll that core stage out December of this year. Boeing, who's the prime contractor on that, says they'll do it earlier. I think they will. I'm a born optimist, but I honestly believe they're going to do it. And we'll deliver that to Michoud Assembly Facility to Stennis Space Center in Mississippi, where it will go through that Green Run core stage test that'll be happening throughout next year. So that is where we are with the rocket of Artemis 1. But we do have other piece parts. I mentioned the payload. Don't say I said that. They'll have their feelings hurt. But the Orion spacecraft, you can see some of their progress here. They're doing great. They had their attitude control motor test firing earlier this year. They've got their modified rack. We all care about our tooling because you don't get that stuff around with a front-end loader. You got to have the tooling. You can see here the uprighting system test that they did. It's getting ready for integration down at the Cape here. And then preparation for mating and checkout in the high bay. So they're making great progress, and I believe Barb Zelon, who's my counterpart for Orion, said that they will be completely through with the spacecraft by mid-June. So we're talking about another week or so. So, does that surprise y'all? Has this seemed like far off to, when I'm telling you we're going to roll the rocket core stage out in December, does that seem, are you surprised? There's a lot of progress. Then talking about ground systems, let's see if I can get to their progress. They have had no small undertaking there. What they've had to do with the vertical assembly building to stack the rocket, they've had to add 10 platforms. They've replaced all of the bricks in the flame trench. And it's interesting because we're talking about hardware, and then they say, hey, look, we've got 170,000 cubic bajillion feet of concrete and rebar. But when you're launching a rocket, that actually matters. So we need them to do what they're doing. And they've made a lot of progress down at Kennedy Space Center, and they'll be eager to receive all the pieces. They already have some of our booster motor segments. They already have the Orion. They already have the European Service Module. They already have the in-space stage of the rocket. So it's all rolling. So I said I would talk you through Artemis 1 a little bit. So this is the launch in 2020, uncrewed around the moon to test out the systems of SLS and Orion. And we're talking about navigation and does the rocket talk to the spacecraft, all of those things. And I'm not using technical terms at all. But we're going to do one lap, and I think it'll replay for us. One lap around the Earth. We'll go through the Van Allen radiation belts. And all the while we're doing that, we're dropping those 13 CubeSats at 5 different spots we call bus stops. So they come out like it's like a Pez dispenser. Once the rocket separates, then they just float out in this really delicate little ballet dance, and they're doing all kinds of science, lunar, solar, asteroid, all kinds of things, solar electric propulsion, and then we'll go around the vicinity of the moon, test out all those systems, and then come back. Really, really important test, because the next one we're going to put humans on it. And of all the things that we're building, the most fragile piece of this entire architecture is the humans. And so to make sure that we're ready for them, we'll be using Artemis 1 for that test flight. So somebody, we talked about speed in the beginning. Why now? Now, you don't need to ask me why now, because I'd ask you why not. And I'd say that if we were talking about brushing our teeth. Why now? Why not? Come on. Do we need to do it? Are we going to do it? Do we want to do it? Then let's do it now. And what we have now, honestly, is the capability, the purpose, the charge, and the responsibility. And capability, in my mind, being our responsibility. And we have enjoyed the support of Congress, both houses, for quite some time, and we have strong support from the administration and the National Space Council and the National Space Club. Some of y'all are probably members. But the time is now, and the point is that we are going, and we are going to stay.
Marcia?
One second. Don't mess up my drama.
Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this calling. We are NASA. And after 60 years, we're just getting started.
You pioneered the path to the moon from this town right here to the Apollo missions and made an Apollo generation. And we're following in your footsteps and we're help growing the Artemis generation. And we are going. We're going together and we're going to stay. And I'm wide open for questions.
Marcia?
Yes, sir.
Did-
Yes, sir.
I have a whole bunch of technical questions, but
Well, then you're with the wrong.
but I'll skip the. Did I notice you got your picture in that movie there?
Yeah, I usually have a version of that where they take my head out because I can't tell you that.
I know, but is there a lead center and is there a designated program manager yet?
There is not. There's not a lead center.
Is there a designated program manager?
There is not a designated program manager. The Exploration Systems Development is led by Bill Hill with 3 program managers, John Honeycutt for SLS, Mark Kirisich for Orion, and Mike Bolger for Exploration Ground Systems. There is the mission manager for Artemis 1 is Mike Seraphin, and the launch director is Charlie Blackwell Thompson, a lady, Charlie, that's also in a lot of these videos. But so the structure is there. I'm not saying that they won't, things are changing quickly. So there's a lot of things that may change in that realm that I'm not aware of yet.
Well,
I usually find out when y'all find out.
Well, there's the mission and there's development that's required to go to the mission.
Right.
Like, where's the dynamic test vehicle test going to be conducted? When is the cluster firings? All
So
those things.
let me say this, that's very different, and I'm just now gaining this kind of understanding, so you guys who really do know, y'all can feel free to correct me. We have never, so one of the hot topics right now, am I overrunning y'all's time? One of the hot topics right now is green run, core stage green run. It's a green run of the flight test article, which we've never done before. Part of that is because the way the program and the enterprise was structured in the beginning was that we would build in parallel the structural test, the qualification articles, and the flight article. So we will be, that core stage green run flight test will be, in effect, a test, but it'll be on the flight article, which brings into question a whole lot of things. You know, do we run at the full duration of 8.5 minutes? Can the hardware, you know, can you hold it? We didn't mean to hold this thing down, right? You don't want to hold down a rocket for 8.5 minutes, but that may be, you know, that's part of the green run. Can we learn what we need to learn in 200 seconds? How many have been to an RS-25 test fire? Yeah, so I'll tell you what happens there. You're so excited, like before you get, and I've seen a few and I still get excited. And you go down there and you get your earplugs in and you're waiting and it fires and you're standing there, everybody with their cell phones up, watching. I'm going to start timing when people start going, wow, okay. Oh, wait, are we still going? It was 560 seconds. It is a long, long time. And so they're looking at right now, there are studies going on, can we get what we need to get with a shorter duration test, and how much refurb do we need to do? This is a flight test. This is, Artemis 1 is flight test. You know, it's, so there's some things that we can do that we wouldn't have to do if you were having to certify for humans, but we do need to wring this Artemis 1 vehicle out because the second one will have humans on it. So
Is there going to be a dynamic test vehicle and dynamic test?
There's structural tests going on right now.
I said a dynamic test vehicle. Is there going to be?
No, there's not. There are the qualification articles and the flight article. That's what we have. Yes, ma'am.
I know that right now tariffs seems to be a big issue. Will tariffs have any kind of impact on the development of everything else that needs to be done on this, on the expenses?
That is a political question way above not only my pay grade but my interest. Actually, one of the things that I do think is unique about the international partnerships, as I mentioned earlier, sometimes when you don't play well on Earth, somehow you play well together in space. So it could be, I don't know, that kind of a political, I wouldn't even speculate. Right. But I can tell you that they are in active conversations with every single partner that we have on the International Space Station, and I think there are 15 international partners. So, yes. There's back here.
How large is the lunar outpost concept they're looking at right now?
The lunar outpost on the surface of the moon or the gateway?
The gateway.
The gateway I couldn't tell you the exact size, but I can tell you it consists of only what's necessary, so that power and propulsion element, a utilization module, which is very small, and then they will aggregate a lander at the gateway. So it's only what's absolutely necessary. And I probably, do you know how large as far as size, is there anything we can compare it to? Yeah, I can find that out. I don't know. And I'll tell you, it's gone to this Gateway Light in the last 2 weeks.
Okay. Yeah, I'd appreciate it if you get that information.
I can do that. Yeah, and if you give Mr. Stokes or somebody your contact, I can get that to you.
Question, are we considering using the HAB module that sits over in 4708 for this?
In Deep Space Habitat Building, I don't think so. I don't know that for sure, but they're in the Deep Space Hab Building, which is one of the coolest places to tour at Marshall. Also historic with the lunar rover work being done there. They have an ISS derived habitat, and they have an SLS derived habitat, much like using the second stage of the Saturn. Was that what Skylab was? Third. So it's a similar idea, but I don't think those pieces themselves will be used. I think those are just, what can we do?
But we had a flight habitat module that was built for ISS that did not fly. We used the Russian vehicle for the habitation modules. That particular module hardware is sitting over in 4708.
Yeah, I'm not, that part of it, I don't know, Mr. Stokes. I just don't have that kind of insight. Yes, sir.
Aren't we going to have to take up fuel for the lander on every mission?
That I do not know. I mean, the point is to get to a situation where you're in situ resource reutilization.
Or you're going to have to have a huge storage facility up there or take it up on every mission?
I don't think that right now, I don't know that, Mr. Zoller. I don't know if they're carrying up fuel on every one or not. I would imagine in the beginning, I don't even want to speculate because I just don't know. Yes, sir.
Do you have a contract with the new Lunar rover?
New
Lunar rover.
We do not.
Are you going to have one?
Yes, we will.
In 4 years.
Well, we will not need a lunar rover in 4 years. So I talked about at the very beginning, there's 2 phases to this thing. Phase 1 from now to 2024 is get there fast with just what we need. So we're going to need a lander, we're going to need that gateway, and we're going to need a launch vehicle and a spacecraft. And we're going to need those lunar surface payload missions and scientific missions to help us figure out. But we won't need a human lunar rover at that point in time. We will need a human lander, but not a rover. Yes? Well, and I can assure you that what I showed you today, have me back in a month. I mean, they are moving swiftly and smartly, and I think that they are doing everything they can. But I will say that everybody initially is laser focused on that first launch of Artemis 1 and then getting to Artemis 3. Yes, sir. But there will be, as a matter of fact, I just heard the administrator say last week, when the first woman and next man step off of the lunar lander on the surface of the moon, there will be significant, meaningful science to be done based on those the rovers and landers and scientific payloads that they're sending up ahead. So the answer to that is they do plan to do science.
I have a bit of information for you.
Oh, good.
When you said there's no dynamics test vehicle on SLS, and I heard a sort of gasp from some of the old hands, the SLS is going to have modal testing during the build-up at KSC and
Yes.
on the rollout. So it's not untested, but there's no separate vehicle.
Right.
Just thought you'd like to know.
In Apollo, we had George Miller, who really,
All up testing.
and George Miller really made a difference on Apollo. He enabled us to get that done in that decade. Do we have anyone like that now in NASA? Who's really the guy in charge who's running the show?
Technically?
Managerially and technically.
That's a that would be difficult for me to answer. I think sometimes, did you know it was George Miller when it was happening?
I met him several times, yes.
Yeah. But I mean, did you realize that he's, like, some of the decisions he was making is what was going to make it do or die?
Yes.
I do think, I can tell you who people trust for human exploration right now in and around the White House and technically, and that's Bill Gerstenmaier. I'm not sure he's right on everything, but I can tell you one thing, if he's wrong, it's not without some gigantic brain power and some serious thoughtful consideration, and he tests the engineers on the ground to give him the data he needs to make those decisions. So I would say he's the pusher right now. He lives in a very different world than did Dr. Miller, and we have some things that we didn't have back in the 60s, the infrastructure, several things, the kind of simulated testing we can do. But we don't have 4% of the budget, and we don't have a blank checkbook, and the way we're doing it is very different. So I think that one of the things Mr. Gerstenmaier is very good at is understanding. He talks about operating under the principle of fiscal realism, and I think after the decades he's been at NASA, he's real clear on the fact that we, as much as we want it, and as much as some people in the general public would want it, nobody's going to back a truck up and dump a bunch of money on us. So he really puts things out in a long stretch to try to figure out do now what we can do now and build towards the future, but understand that they're, you know, that we don't have that situation anymore. I think this is the closest, and y'all tell me what y'all think. To me, this is the closest we've gotten to an Apollo-style feel with the administration, with a president who wants to go, with a House and Congress that wants to go, with an administrator who wants to go, and the capabilities and enough development along the way that we're there. You know, I think, to me, this is as close as we've been in the time I've known, you know, which isn't nearly as long as some of you guys, but the feeling feels, it's not just positive, and it's not just encouraging, it's different. And as I said, when they say on these videos, we are going, I believe it. I believe it. Anybody, another question? Yes, ma'am.
Yeah, you said earlier, early on when you were talking about, I guess, the private entrepreneurs who will be submitting their project idea, and you would buy one. I'm wondering if there's other benefits that they would get if NASA decides to go with their prototype.
That I don't know. I can tell you one thing. The endeavor to do it is bound to pay huge economic benefits to any company. You've been selected as one of 9 companies. NASA selected you as one of 9 companies that we believe you can do surface missions on the moon. And you're, I wish I could remember one of their names right now, and I can't. That's embarrassing because I should. But imagine, imagine what that gets you, and imagine what you learn in the process of trying to do these things. New technologies like crazy. Yes?
I just wanted to help you out with that one. With one of the companies, actually an interesting story. Moon Express was rather lacking in funding, and if you were reading the articles, they were laying people off, closing facilities. And they were selected as one of the initial Eclipse awardees, and immediately after, you had the founder out on Twitter, and he says, we raised all this money from venture capital just because we're on this short list of NASA possible contractors. And so I thought that was a neat story as to how that works. Comment.
Yeah, it kind of, I'm trying to think of something that you can equate it to, if I'm an athlete and I want to be a public speaker and I tell you I was on the U.S. Olympic team for whatever, all of a sudden, you might want me, even if you've never heard my name before. And I feel like not just NASA's confidence in your ability to do that, but the fact that that you're endeavoring to do that. The next industrial or the next revolution, in my opinion, which is worth nothing, but is going to be a space technology revolution. And I think you're seeing the beginnings of it. So I don't disagree with what you said at all. Anybody else? Yes, sir. Here you go.
How much do you sense that risk aversion is not going to hold us back, that this is risky business, people are going to die, we shouldn't bring the program to a halt because it's just the nature of the beast in a frontier like this? And you're hearing there are a lot of old guys that are too pessimistic that I talk to and say, well, you just need to get out of the way.
Yeah.
Because I remember how we got to the moon. And we worked weekends for no pay in unair-conditioned buildings and never thought we wouldn't do it.
Yeah.
I'm fearful that there's so much hand-wringing, a risk aversion.
I think that's going away. Let me take that back. I think that some of it is being mitigated, and I'll tell you why. Because I have said for a long time, and I'll just admit this is straight up parochial. I work for SLS, and I believe in SLS and what it provides. And I've asked people who I trust and who would tell me, you're crazy, you also are buying into a fairy tale, who I've said, am I buying into a fairy tale? So all that aside, still, so I'm saying, that's my part to say, I'm bought in. SLS is tattooed on my back. No, it's not. But we do not have this, we're not We're held to a very different standard, not only by the government, but by the American taxpayer about the risk you're willing to accept with us. I think, and this is just my thinking, I believe that SpaceX or Boeing or somebody else could have a catastrophic incident and lose lives, and it would be more palatable than it would if it was NASA. I think that now, and I'm going to tell you that's just Marshall Lindstrom. Means it's not based on anything except what I think and what I feel. But I will tell you that the recent incident with the Dragon, with its thrusters, I think the fact that that Boeing and SpaceX are experiencing challenges with the development of their human spacecraft just to go to low Earth orbit. I think people are getting back in the mind. You know, I'll tell you what, you guys cursed us because, you know, we did Apollo and oh my gosh, and it became, you know, and then we did Space Shuttle, and then we did the International Space Station, and all of it's, except for a couple of instances, it got to be mundane. I mean, you might not have turned on the television for a shuttle launch, but because it was routine, you know, and it got routine. And so people begin to think that space travel, space exploration, I mean, it's routine. It ain't routine. And I think people are understanding, again, that it is not routine. The vice president himself has said, we're going to fail, let's fail smart. I think there is a slow turning of that knob that says exploration is expensive in every measure, no matter how you're measuring it. And I think that people are willing to say, if we're going to explore, you need to understand the risks associated. So I do see that. I've said for years, we're so risk averse, I feel like that thing's coming back just a little bit because you're understanding it is a dangerous business in a hazardous environment. Yes, sir. And you know, nobody wants that, and it's something everybody knows. That, and I hate to sound cliche, but you know where you were if you were alive when any of those things happened. And but I think we've got a couple of astronauts in the room. I mean, did you know the risk, Colonel Springer, when you signed up?
Sure.
Were you willing to accept it? I mean, you know, it's a risk. And those folks that say, I'll go, is the same thing. You know, you heard I was an Air Force veteran. When I stood in the MEP station and raised my hand and swore to protect this country against enemies, both foreign and domestic, I knew what that might be, and I was saying, I promise and swear I'll do it. And I understood on some goofy level, whatever you can at that point, that there's risk involved. And I think that we're getting into this business, and I think that the tide is turning, that we want this exploration, and we're willing to accept some of the risks that come with it. And we've always had an exceptional astronaut corps. We began having a more diverse astronaut corps with the shuttle in 1979, was that the first class? And the astronaut corps now is made up of, you know, not just gender, not just ethnicity, diversity, not just, you know, it's skill set and background and all of these things. And these are crazy, capable human beings like they've always been. And they're ready. They're ready to ride. I told one of them that hadn't flown yet, that worked with us on something, he said, please send me so-and-so. And I said, all right. And I said, by the way, we'll save you a seat. So, well, y'all, I see Joe's ready to get the shepherd's hook out. So thank you very much, and I'm happy to talk to you up here.
Thank you. Thank you, Marcia. I will say with Maxar being awarded the propulsion unit, a few years back, NASA did award contracts for habitat prototypes for Gateway, and there were 5 companies, and I'm going to insult somebody, but I know Boeing, Lockheed, Sierra Nevada, Bigelow, and one more was awarded. So if you go about 100 paces down the hall here, Lockheed has their prototype Gateway habitat module on display here at the Rocket Center. The Boeing one is out at Marshall, and they have just wrapped up with Northrop Grumman They've wrapped up all of the evaluations on those habitats here in just the last week or so. So progress is being made, Marcia. And if you want to see what it might be that astronauts would walk into when they arrive at Gateway, right down the hall, you can take a look at that as well. I want to thank Rebecca Hitt, Heather Roden, April Adcock, and Dr. Kay Taylor. These are all the folks who work behind the scenes to put these things together, along with our technical folks. And we thank all of y'all for doing that. We have another program next week. Next week is the, I got to get out my sheet and look. We have 40 of these, thanks to Jack and Heidi and folks. But next week is June 13th at 2:30 in Discovery Theater, right here. Engineers of the Apollo Era, moderated by Mickey Allen. So we'll be recognizing some key engineers and managers who made the Saturn rocket a success, expressed from an insider's point of view. We have forward-looking and backward-looking, and celebrating the past and inspiring the future is our theme during the anniversary year. In 2 weeks, we'll have the center directors of Marshall Space Flight Center here in Discovery Theater, and that panel will showcase accomplishments and challenges during leadership of each of these directors at Marshall, and there were many of each. And then also on the 20th, Richard Hoover will present at the Huntsville Library at 6 p.m., emphasizing Marshall's roles in manned rockets and how we're going to do what Marcia says we're going to do going forward back to the moon and on to cosmos exploration. These are really great panels, and they have not been disappointing, so make your plans to attend. So Beer Garden starts within the half hour, if I'm not mistaken. You've got time to visit for a little bit and then head over to the Davidson Center for tonight. Thank y'all very much for coming. Thank you very much.
3, 2, 1, 0.